Okay, for this lesson we're going to be talking about function notation, which is essentially a special way of writing equations. So our first example, we want to evaluate f of x. We want to evaluate f of x equals negative 4x plus 7 when x is 2 and x is negative 2. Well, this is just the process of substitution. F of x is just a fancy way of writing y. So you can write that as a note. F of x means y. And x just means x. So what we're going to do is we're going to substitute x in here and here and see what we get out. So, f of, well guess what, there's also an x here. So let's substitute it in there too. So this will be x of 2. Let's do this one first. F of 2 is equal to negative 4 times 2 plus 7. And that's going to be negative 8 plus 7, which is going to be negative 1. Also, this represents a point. If x is 2 and f of x is y, then y is negative 1. This is also the point 2, negative 1. It means the same thing. Now let's do the other one. X is negative 2. So this time I'll have f of negative 2 equals negative 4 times negative 2 plus 7. This will give me 8 plus 7, which will give me 15. And once again, this can be written like a point. This is the point x, y. It's the point negative 2, 15. So, this is going to be the biggest piece of important information for today, knowing that f of x equals y. Here's x, here's y, and we can transfer this to a point x comma y. Okay. Let's take a look at our next example. Let f of t be the outside temperature, t hours after 6 a.m. We are going to explain the meaning of each sentence. So f of t is the temperature. T is the time since 6 a.m. So t is the time since 6 a.m. So this is 0 hours. It's not how you spell sense. Since 6 a.m. And f of t, this whole thing, equals 58. So that's 58 degrees. So at 0 hours since 6 a.m., well, that's just 6 a.m. So this means at 6 a.m., the temperature is 58 degrees Fahrenheit. Here we have f of 3. This is 3 hours since 6 a.m. Well, 3 hours after 6 a.m. is 9 a.m. And that is less than f of 9. 9 is 9 hours since 6 a.m. 9 hours since 6 a.m. is 3 p.m. And remember, f of t is talking about temperature. So this one is saying that the temperature at 9 a.m. is less than the temperature at 3 p.m. because the whole thing means temperature. The inside is hours since 6 a.m. The whole thing means temperature. The inside is hours after 6 a.m. So, at this point, go ahead and pause the video, try this one on your own, and then press play to see if you got it right. So here, in this situation, x is -4, so I'm going to plug -4 in for x. So this becomes f of -4 equals -4. There's a negative outside here, but x is -4 as well, so -4, minus 1. F of -4 is equal to 4 minus 1. That's going to be -3. And then we can always write that as a point, and that's going to be the point -4, comma 3. Alrighty, next example. We have been given this equation, h of x equals 2/3 x minus 5, and we want to find the value of x for which h of x is -7. So this is a little bit different of a situation than what we've had before. This time, they gave us h of x is -7, and we're looking for x. So this time we're going to substitute in a different location. We're going to substitute in for h of x right here. So this will become -7 equals 2/3 x minus 5. Because h of x, that's what we're substituting in this one. And then we solve like normal. First we'll add 5 to both sides. Then we'll get -2 equals 2/3 x. And then this is 2/3 times x, so we want to divide by 2/3, but we don't ever want to do that. We always want to multiply by the reciprocal, like so. And this will give me -3 equals x, which variable always comes first, so x is -3. And then if I wanted to turn this one into a point, x comma y, -3 comma -7 will be the point for this one. Alrighty, now let's graph in function notation. This is actually really easy because f of x is y. So all you need to do is make a table of values, x, but instead of y we'll call it f of x, x, y, and then you just go ahead and plug in some numbers and figure them out. So values for x, we don't have a situation here, so we don't really know what x needs to be. So I'm just going to pick some random numbers. I'm going to go with, so that I'm equally around the x-axis, I'll just do -2, -1, 0, 1, and 2. You can pick whatever x values you want, but generally these 5 are going to make it the easiest, and you're going to get the best picture of the graph. So, now all we do is plug them in to find our y or our f of x values. So for -2, we are going to plug -2 in for x and see what we get out for f of x. If you need to show work for this, go ahead. So plugging -2 in, I get -4 plus 5, and I get 1. So that's -2, 1. For -1, I'll have f of, well, I don't even have to say, well, yeah, we can leave it as f of x, that's fine. Or you can plug -1 in for there as well. 2 times -1 plus 5. This is -2 plus 5. And that's going to give me 3. If I plug 0 in, I hope you know that 2 times 0 is 0. And 0 plus 5 is 5. Let's show our work for 1. Even though it's pretty easy, f of x. And like I said, if you want to make it f of 1 equals 2 times 1 plus 5, for this, I don't really care if you write it like this or if you write it like this. It's up to you, whatever you want to do. So f of 1 will be 2 plus 5, and that'll give me 7. And then f of 2 will be this, and then it'll be 4 plus 5, which will give me 9. So just like yesterday, these become points on our graph. So I'm going to graph -2, 1, -1, 3, 0, 5, 1, 7, 2, 9. And then, because we don't know anything about this situation, we don't know if the domain is discrete or continuous, there's not a word problem involved. Anytime that you don't have all the information, you are just going to absolutely connect your points and give arrows on both ends. All right. Okay, once again, I would like you to please pause the video and do this one on your own. And when you have it complete, go ahead and play again and make sure that your solution matches ours. So now, once again, we're solving for x, where g of x is -1. So I'm going to plug -1 in for g of x. So -1 is equal to -1/2 x plus 3. And then I'll solve for x. So -3. -4 is equal to -1/2 x. Multiply by the reciprocal. And I get 8 equals x, which is x equals 8. And if I want to write it as a point, x comma y, 8 comma -1. Alrighty, last one. So we got a story problem here. This graph shows the number of miles a helicopter is from its destination after X hours on its first flight. On the second flight, it goes further, but increases its speed. So even though it's going further, it's also going faster to counteract that. And this equation represents the second flight. Still, f of x is the number of miles from its destination, so that's why we see it going down on this graph. And x hours is the time elapsed on the flight. Which flight takes less time? So this is the first flight. Let's read this graph here. These are the distance in miles from its destination. So it looks like it was 300 miles away from its original destination. And when it gets to 0 miles away, we've hit 3 hours. So I don't actually have to do any work for that. That point right there tells me that the first flight took 3 hours. Now, to find out how long the second flight took, well, the distance from its destination, this is x. Oh, it's already written there. This is x. This is f of x. When it's reached its destination, f of x is 0, right? Because that's its distance from its destination. So when it reaches its destination, f of x is 0. So what we're going to do is plug in 0 for f of x. And that's going to represent being at the destination. Because if you're 0 miles from your destination, then you are at your destination. And then we're going to solve for x, which will be flight time. So here's my equation. 0 is equal to 350 minus 125x. So let's solve. I'll subtract 350. I'll divide by negative 125. I'm running out of room here. And I get x is equal to 2.8 hours. But the question was, which flight takes less time? Well, the first flight was 3, the second flight was 2.8, so the second flight takes less time because, sorry, that was a horrible U, because, we're explaining, 2.8 hours is less than 3 hours. And that will be my final answer.